Well, hello, welcome along, Explorer. Look at this. Wednesday's just got smarter with the Fun Kids Science Midweekly, your mini science special. My name's Dan. I'm delighted that you're here. This week, Max asks how lightning and thunder form. Paula wonders why diamonds are unbreakable. We've got Madison who wants to know how people name storms. Tilly's asking how bubbles are made. And Jenny is intrigued about who created the English language. Let's get one on then. This is from Max. What do you got, Max?
How is lightning and thunder made?
All right, how is lightning and thunder formed? Well, when a cloud gets really big and really tall, when it's full of water and it gets heavier and heavier, it can turn into a thunderstorm cloud. Now, inside the cloud, there are tiny pieces of ice and water, and they're moving around very quickly. They're jostling. They're bumping into each other as they circle through the sky. And when they bump around a lot, they get charged up. They make electricity. These are positive and negatively charged particles. That's the way electrons work. You get a plus, you get a minus of them. The problem is, if the cloud gets too much electricity, too many of these charged particles, it needs to get rid of it. So some of those charged particles jump out of the cloud, but they are electrically charged particles. They're electricity, so they make a spark, right? Have you ever had a static shock? Like when you touch an escalator, you know, when you're going downstairs, those things that move, when you touch those, sometimes you get an electric shock, don't you? A little static. Or when you touch metal, when you've been moving around. It's because a tiny amount of electric particles is jumping between you, your finger, and the metal. So that's what's happening with lightning, but on an enormous scale. Giant electrical charges, bustling particles leaping from the cloud to the ground. They kind of meet in the middle, actually, is what happens. They attract each other. That is how lightning and thunder is formed. Max, thank you very much for the question. This is from Paula, who wants to know, why are diamonds unbreakable? Well, technically, diamonds are properly unbreakable. They are the hardest substance in the world. Diamonds are made out of a single element, carbon, which is one of the simplest elements in the world. And what happens is all that carbon gets pushed together deep underground from rocks and from dead plants and stuff like that. It gets squashed and squashed and squashed and squashed, and it gets pressed together and it binds. And that's what makes it very strong and very hard. But not completely unbreakable, right? Because if it was completely unbreakable, you couldn't chip it off to get diamonds that you can buy, right? You might have seen rings with diamonds on. Well, you couldn't get those if it was actually unbreakable. But it is incredibly tough. It's all that carbon squashed, bound together through million years of pressure that makes it pretty much the hardest substance in the world, Paula. Thank you very much. Madison is in Edinburgh, sent me this. Loads about storms this week. We had lightning and thunder earlier, didn't we? This is from Madison, who wants to know, how do people name storms? It's done by the World Meteorological... I always struggle to say that word. The World Meteorological Organisations. There's a lot of those, meteorological. Anyway, they are like the weather forecasters of the world, and they name storms. It's done in an alphabetical order, switching between male and female names on a 6-year cycle. After 6 years, they go back to A and they think of more storms. The most recent storm we had here in the UK was called Storm Kathleen. That was in April, and they've already planned them. Hang on. I thought they switched between boys and girls. That's what I said, but the next one is Lillian, Minnie. Then you've got Nicholas, Olga, Piet, Regina, Stuart, Tamiko, Vincent, and Walid. So that's the storms that are planned. And as I say, they do rotate in a 6-year cycle. I thought they switched between male and female names, but I'm not sure if that's absolutely true. Anyway, there you go. That is how they come up with storm names. It's the job of the World Meteorological Organization. Let's get another question on. This is from Tilly, who is 9 years old and wants to know how bubbles are made. Do you mean the bubbles that you make in the bowl, which you throw into the air? It's all to do with the soap and the water. See, the soap is strong enough to wrap around a little pocket of air. It stretches all the way around and it binds to it. It clings to each other, but traps air. Then it rises and it floats through the air. But they burst because soap bubbles are drawn towards other soap bubbles. They're attracted to each other, so they can pop when they touch. Or the water that the bubble is made of with the soap gets too hot and it evaporates, so it's not there anymore, so it pops that way. But that's normally the two ways that bubbles are made. Let's get one more on, shall we, this week? This one is from Jessie, who is 11, who wants to know who created the English language. Well, English is a language that has evolved over a long time and it's constantly changing. In the early part of the 1st century, about 400 years, AD, 400 AD, so that's 1600 years ago, England was home to lots of different people from all over Europe. Lots of people from Germany were here, and the English language developed from how they would speak. But it's constantly changing as different people from unique countries come here and they slightly change things. Think of it like in your friendship group at school or wherever it is, do you have like a way that you talk to each other? You say words that you all understand, but maybe other people might be confused by. Well, that's what happens when groups of people are left in a space for a long time. And that's what's happened with languages over thousands and thousands and thousands of years. We are taught how to speak in the language by our parents and from our teachers, and they were taught by theirs. So that's how it gets passed down. English has evolved over a long time, from about 400 AD. Thank you so much for the question. Brilliant questions. Make sure you keep them coming. If you've got one, head to funkidslive.com, hit the big red button while you're there, and it will come through to me so I can do all the digging for you. While you're on the Fun Kids website, have a look for tickets to Fun Kids Science Weekly Live. We are less than a month away from the very first show of our very first live tour. We're going all around the country, stuffing your summer full of science, explosive experiments, genius guests, slimy things, deadly beasts, and your chance to hold something extraterrestrial. It's all on the way this summer, the very first Fun Kids Science Weekly live tour. You can find out where I'm playing near you. Get a grown-up, head to funkidslive.com/tour. And it's time to meet Amy then, who loves planes and aviation. And we're listening in to find out all about the different kinds of planes and how they work. This week, Amy is searching for satellites.
Amy's Aviation, with support from the Royal Aeronautical Society.
8, 9, 10... Oh, hi there. Have you noticed how the sky is a pretty busy place? It's estimated that there's over 20,000 planes flying around at any one time. So you don't normally have to watch for long before you'll see a plane overhead. But there's also much more going on up there than you might realise. Most large aircraft you can see aren't travelling much higher than about 35,000 feet. That's about 10 kilometres. But there's plenty of other objects flying around thousands of kilometres above the Earth. They're called satellites. A satellite is an object that orbits another object. Our moon is a satellite, and the Earth itself is a satellite of the sun. And then there's the artificial satellites that we've placed in orbit around the Earth. It's estimated that there are over 3,600 artificial satellites in orbit, of which around 1,000 are operational. The rest are just floating around, having done their work. Approximately 500 of these operational satellites are in low Earth orbit. That means they are up to 2,000 kilometres above the Earth. 50 are in medium Earth orbit, around 20,000 kilometres away, while the rest are in geostationary orbit, around 36,000 kilometres. The very first artificial satellite was called Sputnik 1 and was sent into space in 1957 by the former Soviet Union. Now, you might think that it's just the Americans and Russians that launch satellites. Well, you'd be wrong. In 1962, the UK worked with the Americans to launch the first international satellite. This was called Ariel 1, and it carried 6 British instruments to investigate the space environment. And in 1967, we built our first very own 100% British satellite called Ariel 3. Today, the UK has a reputation as one of the world's leading manufacturers of satellites for science, communications and navigation. Each satellite carries a unique set of instruments or technology relevant to the mission. A communication satellite will need large antennas to receive and transmit television and telephone signals to Earth, while a disaster monitoring satellite will have cameras to take photographs of the land below. To work properly, most satellites need to stay in the same orbit. This is achieved through a combination of speed and the gravitational pull between the Earth and the satellite. You can simulate this gravitational pull by swinging a ball tied to a piece of string in a circle above your head. If the string breaks, the ball would fly off in a straight line. But because it's tied to the string, the ball safely orbits your head, just like the gravity on a satellite. In addition to providing satellite TV and operating your parents' sat-nav, satellites do a variety of really useful jobs. Here's some clues to some of the jobs they do. Communication satellites, like the British HILAS and Hotbird satellites, are responsible for delivering radio, phone and broadband signals to our homes, in addition to high-definition TV. Then there's satellites like the Hubble Space Telescope and the International Space Station that undertake scientific experiments and observe the universe using powerful telescopes to make new discoveries about stars and planets. Both of these contain lots of scientific equipment that was made in the UK. Other satellites observe what's going on around the Earth. A satellite called GOCE is monitoring the movement of the oceans, while Cryosat-2 is watching the ice caps. Natural disasters such as typhoons, earthquakes and volcanic eruptions can cause major devastation. A group of satellites called the DMC help provide pictures of what's happening so relief teams can get help to where it's needed the most. There's just time to check out a very cool new type of satellite. They're called CubeSats. The clue's in the name. CubeSats are, well, small cube-shaped satellites. The best thing about them is that because they're so small and light, many can share launchers to get them up into orbit. It's a bit like sharing a lift. And being cheap is very important because the idea is to get students and companies involved in trying out experiments in space, not just scientists with pots of money. In just one cube launched in 2013, there's a device to measure space weather, a camera to take images of the Earth, and an experiment using cosmic radiation, all in just one satellite smaller than a football. I wonder if you could think of a cool experiment for a CubeSat to do. The sky's the limit.
Amy's Aviation, with support from the Royal Aeronautical Society. Find out more about aviation at funkidslive.com/aviation.
You can find out more about Amy Aviation. Head to funkidslive.com/learn. And that's it for today's Fun Kids Science Weekly. On this Saturday's episode, we'll dive into the fascinating story of how humans acquired the amazing gift of language.
So some researchers who look at, I think, whales and dolphins think that there might be more than just simple communication, but we don't know that. If it is a language, we don't recognize it and can't decrypt it to figure out what they're saying. So in terms of evolution, why haven't other species developed it? Maybe they don't have the need, maybe they don't have the brain capacity, but it does seem something that we find in humans.
And Dr. Alex Dittrich is on revealing the chilling mysteries of zombie plants.
A lot of them have really, really exciting strategies. Like, some of them may be parasitic and they may live within the bodies of other animals. Some may be predators, some may be feeding on trees, plants, other exciting things. They may eat each other. They're just wonderful. I love them. They're weird. They're great.
It's all on the way this Saturday in a brand new Fun Kids Science Weekly. I'll see you there.